Good morning, students. I am Meenakshi from Rohini College of Engineering and Technology. Today, we are going to see the topic elliptic curve cryptography under the course Cryptography and Cybersecurity. So, what is elliptic curve? So, this is the graphical representation of elliptic curve. So, curves of this nature are called as elliptic curve. So we can define the elliptic curve over a field K. It is a non-linear, it is a non-singular cubic curve which consists of two variables x and y. So f of x comma y equal to 0 with a rational point. So it can be a point at infinity. So you can define the elliptic curve over a field K as a non-singular cubic curve with the two variables x and y. So the general form of elliptic curve is, it is defined by the equation y square equal to x cube plus ax plus b. And there are all several examples for elliptic curves. Now we move on to elliptic curve cryptosystems. So what is elliptic curve cryptography and why we need elliptic curve cryptography? So like RSA, elliptic curve cryptography, that is ECC, is also a public key crypto system. Okay, like the other algorithms RSA, Rabin, El-Gamal and so on. So since this is a public key algorithm, we have two different keys. One is the public key, the other one is a private key. So we can use the public key for encryption process or signature verification. You can use the private key for decryption process or for signature generation. So normally elliptic curves are used as an extension to the current crypto system, that is Diffie-Hellman key exchange along with the elliptic curve. Similarly, DSA along with ECC. Okay, so it is normally used as an extension to other crypto systems. So the central part of any crypto system involving elliptic curve is the elliptic group. Okay. So usually the public key crypto system have some mathematical operation. For example, in RSA we use the concept exponentiation. In ECC we are using the concept point multiplication, that is repeated addition of 2 points. We move with the algorithm. So we have two different parties, the sender and the receiver should agree on several publicly known items. So they have to agree with the elliptic curve equation. So the equation consists of the values a and p and it comprises the prime number p. Then you have to compute the elliptic group from the elliptic curve equation and you have to take 1 point as a base point. Okay, so these are the things both the sender and receiver should agree with each other. Then each user, that is both the sender as well as the receiver, generates their public private key pair. So for the private key they can choose any integer x in the interval 1 to p minus 1 as their private key. And using the private key, the other person, using the private key, they have to calculate their public key. So it is the product, it is termed as q is equal to x into b, that is the private key and the base point. Okay. Suppose Alice want to send a message to Bob, an encrypted message. First both should agree on a base point p. Then Alice and Bob create their public and private keys. So Alice private key, he can choose it as a, and using a he should calculate his own public key, that is he has to multiply his private key with the base point p. Similarly, Bob can choose any one integer as his private key, and using the private key by multiplying the private key with the base point, she can calculate her public key. So now for every person, that is for both the sender and the receiver, we have the private key as well as the public key. Now we move with the encryption process. Alice wants to send a message. So Alice takes a message M, and that message is encoded as a point PM from the elliptic curve. So what is the formula? Alice chooses another one random integer k. So she can calculate the ciphertext as a pair of points, that is x comma y, 2 points. So the first point is k into b, and the second point is the plaintext message PM plus k into pb. To decrypt the message, Bob computes the product of the first point from PC, that is PC is the cipher point. It is transmitted to the receiver. So at the receiver end, what Bob is doing means Bob compute the product of the first point. So the first point is KB, the first point, and his private key B. So this is the first step. Okay, after that Bob takes this product and subtract it from the second point. So that is, the product is P into KB, and it is subtracted from the second point from PC. So the second point is this one, PM plus KPB minus PB into KB. So it can be written like this, PM plus KBP KBB minus BKB. So these two terms are equal, so you can cut them. We get the plain text PM, that is the original plain text. Okay, thus he can recover the plain text. Similarly, you can go for elliptic curve with the Diffie-Hellman key exchange. So it is also very same as the previous one. So Alice and Bob compute their public and private keys. So the private key, so he can choose any integer. By using the private key and multiplying it with the base point, we can compute A's public key. Similarly, B can choose her private key, and this private key is multiplied with the base point B. Thus, she can calculate her public key. Now, Alice and Bob send each other their public keys. Both take the product of their private key and the other uses public key. Okay, so the product of their private key. So Alice private key is A, and the other uses public key is PB. Similarly, Bob calculates the product. For that, she uses her private key B, and the other uses public key, that is AB. Okay, C A B B. So these two values are equal. So thus they shared their secret key. The applications of ECC. So nowadays we are using many small devices. Example, mobile phones, smartphones, and iPod, etc. All are having a limited storage and limited computational power. So in this application, we can use elliptic curve cryptography to secure the content. So it is used in wireless communication devices, It can be used in smart cards. Okay, so if the web server wants to handle many encryption session, then you can go with the ECC algorithm. In particular, the applications where we have a less power, less storage and less computational power, then you can go for the better choice ECC rather than the other algorithms. Thank you.